Hi everyone. In today's video, we are going to solve this example. Okay. So one differential equation we have. What will I do? I will check first it is exact or not. If it is exact, then our task is very easy. We can easily find its answer. But if it is non-exact, we will convert it into exact and then we will solve. Right. So let us recall few things first and then we will start to solve this example. The differential equation which is in this form. M dx plus n dy. Okay, so this is a standard form when you have exact or reducible to exact type problems. M and n both are functions of x. You can easily see this example. Some multiple of dx we have, so function of x and y, and multiple of dy, that is also function of m and n. Function of x and y. Okay, so that means the given function, given differential equation should be in this form. We say it is exact if dabba m by dabba y is same as dabba n by dabba x. It means partial derivative of m with respect to y should be same as partial derivative of n with respect to x. So for the given problem also we will check first it is exact or not. Okay. So let me note down first our m and n. So let me write here we have what is our m? Multiple of dx is our m. So this is my m, which is y plus y cube by 3 plus x square by 2, right? My n is nothing but multiple of dy, which is nothing but this 1 by 4. Let me write n is equal to 1 by 4 x plus xy square. Okay. So now I'm going to find both these partial derivatives and then we will check whether both of them are same or not. Let us start with dabba m by dabba y. Partial derivative of m with respect to y. You can easily see there are three different terms which are separated by addition. So I will take separate derivatives. Derivative of y, right? Derivative of y cube by 3 and derivative of x square by 2. Derivative of y is always 1 since we are finding derivative with respect to y. Okay, so this is a very basic formula. Derivative of x with respect to x is always 1. Similarly, derivative of y with respect to y, 1. Okay, so here in second term, 1 by 3 is constant, will come outside. So inside we will have simply y cube. I always take constants outside. So here also I took 1 by 3 outside. In case of last term, there is no any y. We have 2 as well as x square. So both of them are constants. Since we are differentiating with respect to y, so x and functions of x are constant. That means the entire term is constant and derivative of constant is 0. So I got the 0 here. So let us solve this one. The first term is 1, right? Plus 1 by 3. We have to find derivative of y cube. So the formula is derivative of x cube is, or I should write general formula, x raised to n x raised to n minus 1. This is a basic formula, right? So if you have x raised to n, some variable raised to n, whatever the power we write first and then we reduce the power by 1. So here the power is 3. So I should write here, I should reduce the power by 1. So it means 2. So the derivative of y cube is 3y square. This is 0, forget it. 3 we can cancel. So 1 plus y square. So finally I got this partial derivative dabba m by dabba y. So the next task is to find dabba n by dabba x and we will check whether both of them are same or not. Okay. Yeah, let us use that space to write. Okay, so the next part we will continue here. Now dabba n by dabba x. So this is my n. We have to find its partial derivative with respect to x. 1 by 4 is constant. I am taking outside 1 by 4. So derivative of x plus xy square, right? 1 by 4. So addition is there. I will take separate derivatives. That means derivative of x plus derivative of xy square. Okay, so let us continue. So you know the derivative of x with respect to x is 1. So I can put it here. Okay. So let me remove this part. So I will get more space to write. So 1 by 4 derivative of x with respect to x is 1. If you think about the second term, y square is constant. Since we are differentiating with respect to x, so y square is constant will come outside. So that y square will come outside and inside you will have simply x. So what is derivative of x with respect to x? 1. It means 1 by 4, 1 plus y square into 1. So it is 1 by 4, 1 plus y square. So this is deba n by deba x. Deba m by deba y, 1 plus y square, and this one 1 by 4, 1 plus y square. Both of them are definitely different. That means given differential equation is non-exact. It is non-exact. So therefore, deba m by deba y is not equal to deba n by deba x. Therefore, given differential equation is non-exact. Okay. So the differential equation is non-exact. That's why we cannot apply the method of exact differential equation here. But see, we will try to convert it into exact. Okay, what will I do? I will try to convert this non-exact differential equation into exact differential equation. If it will be converted into exact, then we can follow our traditional method to solve the exact differential equation here, and easily we will get the answers, right? Wait, okay, what will I do? Next step actually. So the next step is we have to convert this non-exact differential equation into exact. Now the question is, how can we convert? See, what will we do? We will find integrating factor. Integrating factor means a factor, that means it's a function of x and y, such that if you multiply this differential equation by that integrating factor, then it will be converted into exact differential equation. Now the question is, how can we find integrating factor? Actually, there are 4 different methods of finding integrating factor. So let me tell you those methods first. If deba m by deba y minus deba n by deba x, that means difference between these two partial derivatives, divided by n, if it is function of x, then integrating factor is e raised to integration f of x dx. Getting the point? If the difference is a function of x only, that means there should not be any y, then what will be the integrating factor? E raised to integration f of x dx. Second method, deba n by deba x minus deba n by deba y. That means exactly opposite thing I have taken. Now I am dividing by n, and here we should get a function of y only. If you get function of y only, that means there should not be any x. Then integrating factor is e raised to integration f of y dy. The third method is, given differential equation should be in this form: y f1 of xy dx plus x f2 of xy dy. The differential equation should be in this form. Getting this form? That means xy should be there everywhere. Okay, there should not be single x single y, there should be xy, it should appear everywhere. And the fourth method is applicable if given differential equation is homogeneous. That means power of each term is same, then we say homogeneous. So now we have to check which method is applicable here, right? Generally what I do, I will start with a last method. Getting? Because it is quite easy to check whether it is applicable or not. If it is not, fourth one, I will go for fourth one first. If it is not applicable, I will go for third one. If both are not applicable, then only I will go for method 1 and 2. Since in these two methods we need to solve all these things, and then only we will realize getting which method is applicable. Homogeneous, power of each term is same. Power of y is 1, power of y is q 3, power of x is 2. Different powers they have. That means the fourth method is not applicable. Third, xy should be everywhere. But see, here we have just y only, here we have just x only. So the third method is also not applicable. That means just we have two options. Either the first method is applicable or second method is applicable. Without solving, we cannot find that which method is applicable. I supposed to calculate this one, but see, it's difficult to find a space here. What will I do? I will make some space here and then we will continue. Okay. So let us continue. So I will go for the first method. Consider delta m by delta y minus delta n by delta x upon n. Okay. So delta m by delta y, we had got 1 plus y square minus delta n by delta x, this one 1 by 4, 1 by 4, 1 plus y square divided by n. What is my n? This 1 by 4 x plus xy square. Okay. So we are going to solve it and it should be a function of x only. Then only the first method is applicable. Let us solve. See, 1 plus y square, 1 plus y square we can take common. So if you take 1 plus y square common, okay, this bracket I took common, then only 1 is there, minus only 1 by 4 is there. In denominator, 1 by 4. So tell me, what can I take common here? I can take x common. X I am taking outside. 1 plus y square is remaining. X came outside, right? 1 minus 1 by 4, 3 by 4 if you cross multiply. So 3 by 4, 1 plus y square. Denominator 1 by 4, x 1 plus y square. So tell me, can we cancel anything? Yes, definitely. I'm so much happy to cancel this bracket, getting, as well as 4 is also we can cancel. So at numerator just that 3 is remaining, in denominator just x is remaining, getting. So there is no any y. You can see we want just function of x, and definitely this is function of x only. So we call it as f of x. That means first method is 100% applicable here, right? Okay. So let us move further. Our target is to find integrating factor. Integrating factor is e raised to integration f of x dx, right? So e raised to integration, in power of e we are solving the integration. Power of e, f of x is 3 by x dx. 3 is constant, you can take it outside. 3 will come outside, 1 by x dx. What is integration of 1 by x? Integration of 1 by x is log x. That means e raised to 3 log x. Now actually I wish to cancel this e and log, but I cannot do because of this 3. We need to remove this 3. So for that I am going to use this property of log. Log n log a is log a raised to n. I think in previous examples also we have used this property. If you have any multiple of log, you can write as a power of a. Getting? So I can use this property. E raised to 3 is a multiple of log, you can write as a power of x. So we are getting benefit of it. E and log will get cancelled to each other and we will have simply x cube. So this is our integrating factor. That means it has potential to convert the given non-exact differential equation into exact differential equation. Now what will I do? I will multiply given differential equation by this x cube, then it will be converted into exact differential equation. Okay. So for that I need to remove this one. Just a minute. So let us multiply given differential equation by x cube. Multiplying given differential equation by x cube. Okay, I need to multiply this differential equation by x cube. So to both sides, that means x cube into this bracket y cube by 3 plus x square by 2 dx, plus here also x cube by 4 x plus xy square dy is equal to 0. Okay, what will I do? I will solve the bracket, it will be better. So x cube y plus x cube y cube by 3 x raised to 5 by 2 dx on this side also. 1 by 4 we can keep outside. X raised to 4 plus x raised to 4 y square dy is equal to 0. So this is an exact differential equation. That means basically we had non-exact differential equation, we converted into exact differential equation. So this is our new m and that is our new n. Let me write. What is our m? X cube y cube by 3 x raised to 5 by 2, and what is our n? 1 by 4. Oh, you can take product also. So 1 by 4 x raised to 4, 1 by 4 x raised to 4 y square. So this, sorry, my mistake, y square. So this is exact differential equation. We got m and n. So now we have to find the solution of this equation. See, let me tell you, the method is quite simple. Solution, we have a direct formula to find solution of exact differential equation. Integration m dx, we consider y constant, plus integration n free from x. Okay, we want the terms of n free from x, y is equal to c. So this is, we have a direct formula to solve any exact differential equation. That means simply addition of two integrations, first integral, second integral. So what will I do? I will solve these two integrations separately. At the end I will add and I will mention is equal to c. So that will be the final answer. So let us start with the first integral. So consider integration m treating y constant with respect to x. Okay, so n, where is my m, where is my m? This is my m. How many terms are there? 3 terms are there. I will take separate integrations. Since addition is there, x cube y dx, x cube y cube by 3 dx, x raised to 5 by 2 dx. What I do, always I take constants outside. Y is constant. We already mentioned treating y constant. Y will come outside. Here y cube is constant, 3 is also constant. So both of them will come outside. Simply we have x cube dx. Here 1 by 2 is constant, will come outside, x raised to 5 dx. Actually, I want some more space to write. Just make a screenshot of it. Then we will move further. So let us continue. Okay. So is equal to y. Now the question is how to find the value of this integration. So we have a simple formula. Integration x raised to n is x raised to n plus 1 by n plus 1. Whatever the power we have, we increase it by 1 and the same number we write in denominator. So its integration will be, will you tell me what will be its integration? X raised to 4 by 4. Just increase this number by 1 and same number in denominator. Plus y cube by 3 constant outside, y cube by 3 into, its integration will be x cube, same, x raised to 4 by 4 plus 1 by 2 outside, integration of x raised to 5, 5 plus 1, 6, and the same number in denominator. So the final answer is x raised to 4y by 4 plus x raised to 4y cube by 12 x raised to 6 by 12. So this is the final answer. Final, that means value of this integration. Okay, so one more integration we have to solve. The second integration is now integration terms in n free from x. Getting, now we want terms of n which are free from x. There should not be any x. How many terms are there in n? 2 terms. First term, second term. Is there any x? Yes. So we cannot take the first term. In second term, is there any x? Yes, x is there. X raised to 4 is there. So you cannot take the second term also. So that means there is no term in n which is free from x. So it should be 0. Integration of 0, 0. So let me mention the solution is, solution is nothing but addition of these two integrals. Getting, the value of first integral is this one. Let me write x raised to 4y by 4 plus x raised to 4y cube by 12 plus x raised to 6 by 12, and the value of second integration is 0, so no need to add 0 plus anything, you will get the same. So simply I'm mentioning is equal to C. This is required answer. So in this way we solve this example, right? That's it, finish. So this example we solved here, right? So now what will I do? I hope all of you understood how to solve. So if you are really understood, I am going to give you one problem, practice problem for you. You can try that problem on your own. In case of difficulty, you can write to me, or in next video I am going to solve that problem. Okay, just make a screenshot of it, then I will give you the practice problem. So this is problem for practice. You can try on your own. In case of difficulty, you can watch my next video. Get it? Or if you really solve this problem and if you get the answer, you can cross check your answer by watching the next video. Okay, so we are going to meet in next video. Thank you. See you.